All right, everybody's favorite graphing. My thing goes on. Turn that on, vibrate or something. What am I doing? What am I doing? Pausing is what. All right, good to go. We're talking about graphing reciprocal functions. We've got actually 2 lessons of graphing in a row. This one is fairly straightforward. It's not too bad. The next one is another story, but that's next video. Us is problem. Let's dive in. So the reciprocal parent function looks like this, right? A lot of this stuff is more same, right? Like we've seen these same sorts of patterns. Hi, per, whoa, hi, perbola. Hyperbola. Okay, so the parent function looks like this: f of x equals 1 over x. The shape is called a hyperbola. Now, that's typically a hyperbola is actually a parabola and then a mirrored parabola as well. This is not technically a parabola. Neither this one nor this one, because they don't continue getting wider and wider forever. Excuse me. And so they do actually. I guess they do actually. No, they do, because they keep on going up and down, but they don't, because there is a asymptote. In fact, there's a couple of different asymptotes. We've got an asymptote right here, and we've got an asymptote right here. We've got asymptotes at the y-axis and the x-axis right here. The domain and range. Now, this may be a little bit of probably more of a dusting off of cobwebs notification than a brand new notification. With this symbol in the middle is a big U or whatever else. It doesn't have, and we don't draw it like that. We just draw it like a little parabola looking shape, and it means union. So the domain and range are actually the same. It's everything, and what this basically means is it's everything but not including 0. So if we were to write this in kind of our old school notation, the domain and range would be x does not equal 0 and y does not equal 0, right? So that is the domain and range, because we have those asymptotes and we shift stuff around. Let's jump in. It has no intercepts because it never crosses the axes. Let's do some examples to make some more sense. So we want to determine the values of x for which f of x is this thing, right, is not defined. So if we go back to our picture, our parent, this graph, the parent function is not defined at 0. And why is it not defined at 0? It's not defined because the denominator can't be 0. So to answer this question is really, really simple. All we have to do is take the denominator and set it equal to or not equal to 0, right? And then solve that little simple equation. This cannot equal 0, and then we solve for x. Easy peasy, right? So we're going to subtract 5 from both sides, leaving us with 2x does not equal -5, and then we divide by 2 and end up with x cannot equal -5. Bless me. -5 halves. That's easy peasy, right? Let's jump to the next thing. All right, so for these pictures, we've also written in the equations. What where are the asymptotes, the domain, and where is the domain and range? And so basically, we need to, if we start with where are the asymptotes, right, then we can figure out what the domain and range is from that. So, and the domain and range on these are the same, remember? So let's use something that's going to be visible. I guess we'll keep this. So it looks like our asymptote is right here. We're getting closer and closer to 0. Where is the vertical asymptote? Because there's both, right? There we go. So there are our asymptotes. If I erase this, it's going to like put holes in the graph because I rasterize this whole layer. But our asymptotes for this one right here, asymptotes at x equals 3 and at f of x equals 0, right? So x equals 3 is this vertical one, and the other ones are that. Are the other one. The other one is this one, right? The horizontal one. So there's the asymptotes, which means the domain and range, and we're going to just list these together because they're actually the same. The domain and range would be from negative. Oh, they're not actually the same. Just kidding. They're not the same. That's a lie. The domain is from negative infinity, right? So checking over here all the way to 3, not including 3, union, not including 3 to positive infinity, right? There we go. Now, what about the range? Where is the range of this one? Now, the range is just like the parent function from up to 0. So negative infinity, trucking on along to 0, union, 0 to positive infinity. All right, let's take a look at this guy. So where is our asymptotes? Well, it looks like we've got an asymptote right here. And looks like our other one is going to be right there, right? So we moved our asymptote over. Now, one thing you might, if you're kind of looking at the equations and looking at the way the asymptote shifts and looking at these things, you might get a little preview in your head for what's coming in on our next slide where we start doing transformations of these things. So the asymptotes, I think that word does have 2 S's in it. Oh, it doesn't. I don't know why I thought it had 2 S's in it. I don't know. Anyway, asymptotes, it's got one at x equals -2. And it's got one at f of x equals -1, right? Equals -1. Easy peasy, right? Oops. The domain is from negative infinity all the way to -2, not including, union, not including, -2 to positive infinity. There it is. What about the range? Just as easy, from negative infinity, we always go low to high, negative infinity, all the way up to -1, and unioned with -1 to positive infinity. Easy peasy. I'm going to pause and go blow my nose. Allergies, man. All right, welcome back, me. Here we go. Let's do the next thing. Easy peasies. All right, well, there's the big slide. This is probably something you were expecting, both because I said it was coming up and because that's just the pattern of how graphing stuff works in Algebra 2, right? So to translate the one kind of different thing, most everything works exactly like what we expect, or what we've grown to expect, right? And it's just kind of where the things are. So the inside parentheses that we typically talk about is down in the denominator, right? So the H, just like always, is going to go opposite of what we expect because of this minus right there. The K is the vertical translation up and down. This is the H is the horizontal, so shifting left and right. For the translations, you know, it's when we do translations, it's nice to have kind of a reference point of this moves. Like on a parabola, the vertex moves up and to the right or whatever. So I like to think about it as where the center of the asymptote moves. So like if it's a +2 out here, then that asymptote moves up, right? And if it's a -2 over here, then that asymptote moves to the right, you know, and all those kind of things. So the A and the B, so for multiplying numbers, those are going to be our dilation and our reflection and all of those things. For the A, this is kind of that typical A that we're used to looking at. If it's negative, then it flips down. So instead of being like this, it's now like this. Oh, it's now It's not like this. I've drawn too many things, right? We'll see some examples here in a second. And the A is, since it's outside the parentheses, it's all of what we'd expect. So if A is greater than 1, it is a vertical stretch, which doesn't look a lot different, to be honest, than it's if it's what am I saying? It doesn't look a ton different than what it looks like. So I can change that A number a lot, and it doesn't change the picture a ton. So you could try doing some different ones in decimals or something and see how that works. If A is a fraction, it's going to compress, right? Same thing in there, but the B, since it's inside the parentheses, it's all opposite, right? So, but it's not really. It's just horizontally instead, right? So it's for a greater than 1, it's going to have a horizontal stretch, which is going to look like a vertical compression, right? And so that's how it's opposite. And if it's a fraction, it's horizontally compressed. Let's do some examples and put some meat on it, just like we always do, right? So we're going to do 2 examples. Pop up our graph here. First example looks like that. We're going to graph this and state the domain and range. Okay, so we've got this guy. What all changes? It's kind of nice to notate for ourselves what's going to happen. So it's going up 2. So we can go ahead and start dotting in our asymptote change, right? So it's going up 2. So this asymptote is going to change right there. So see what I mean, where it's easy to kind of think about it as where the asymptote moves. That kind of helps us look. And what does this do? Well, this moves to the right 2, right? So, and it's because it's opposite, right? Inside parentheses. And then this one, so that's going to move over here. So our new asymptote is over here. I'm going to make sure those are dashed, right? We like our asymptote lines to be dashed lines because it's not a part of the graph. They're just for reference. So those are dashed lines there representing our asymptote. Okay. So now it's also horizontally compressed, right? So it's going to be easiest to represent that by just plugging in some points, right? And so let's go ahead and find some points here. All right, so we're going to make our little T-chart, X and Y. Now, what values do we want to put in for X? Well, we want to put in ones that are going to be to the left and the right of our vertical asymptote, right? So let's pick like, what is this? 1, 2. So let's do 4, and let's do 3. 4, 3, and not 2 because it's going to be undefined at 2. So let's do 1 and 0. That may be enough to get us a picture, and we may need to do a couple more. Let's see what happens. So if we do f of 4 in here equals 1 over 4 times a half is 2. So 2 minus 2. What did I do wrong? Because 4 is it's undefined at 4 unless I made a mistake. Let me pause and figure out where my brain is broken. All right, so my brain is broken because that is not where the vertical asymptote is. The vertical asymptote is actually at 4, not at 2, because of this 1/2. So to find our horizontal asymptote, it is shifted to the right 2, but then this also gets into account. So we need to figure out what the domain is by setting this denominator equal to 0. So we're going to do 1/2. We already just did this, right? All right. X minus 2 equals 0. And we just solved this on accident because we end up adding 2 and then multiplying by 2 on both sides to get rid of that. So X ends up equaling 4. So we actually have the vertical asymptote not at 2, but at 4, because we need to set the denominator equal to 0 in order to find where that vertical asymptote is, which is, there's actually an error in the way the book we're using describes this. And I was just kind of following along and not really paying attention or really thinking. I mean, I was paying attention, but I wasn't really thinking about what I was doing and realizing, and this is kind of a setup for the next lesson, actually, a little bit. So anyway, all that to say, the horizontal asymptote is there, which means we really need to do slightly different numbers here. So let's pick some different numbers. Let's pick a positive 2, positive 3, positive 5, and positive 6. Right? So here we go. Let's try again. Take 2. Yeah, so we're going to find f of 2 equals 1 over 2 times 1/2 is 1. 1 minus 2 is negative 1 plus 2. So this equals negative 1 plus 2, which is positive 1. All right, I thought my brain was broken again. It was, but we didn't do anything wrong. That's right here at 2, 1. So that point right there. Okay. And then let's plug a 3 in there. F of 3. Now this one's going to be a little bit weird. We're going to end up with fractions, right? We have 1/2. No, not 1/2. 1/2 times 3, which is 3/2, minus 2 plus 2. 3/2 is 1.5, right? So 1.5. We might grab our calculator just to make sure it's clear to what y'all are doing and all of those things, just to make me not just saying words. Let's put something on the screen. Give me half. All right, I'm back. So 3/2 minus 2, which is going to be like negative 1/2, right? But just so that you can see what's happening. So we have 1 over negative 1/2 plus 2, right? Excuse me. So this, how do we divide fractions? We multiply by the reciprocal. The reciprocal of negative 1/2 is negative 2. Negative 2 times 1 is negative 2. And negative 2 plus 2 is 0, right? Oh, I didn't put that in there. So 0 is what we get. So this point right here. Now, these functions are symmetric. They're not symmetric about the axis, either the x or the y-axis, or even the asymptote. They're symmetric about the line that is like the inverse line from here. So that like this would be symmetric across this like over, or that you could describe it kind of, it works out the same way as they have rotational symmetry. So if basically what I'm saying is I can just copy and paste these points over in the same place across in this other place where they exist, right? So I can just copy those and I end up having the same thing. There it is. Easy peasy. This would be, if we want to finish filling out the table, we weren't asked to do so, but if we want to finish filling out the table, this would be 5, 1, 2, 3, 4, 5, 4, and this would be 6, 3. Great. So the domain is from negative infinity to 4, not including 4, and the range would be from negative infinity to 2, not including 2, then 2 to positive infinity. Easy peasy. All right, let's do one more example, and then we will be through. Okay, this last example, we're going to graph this guy, study the domain of range. This time, though, there's no weird B thing happening, and so we don't have to do anything weird. We're just going to, it's pretty much what we'd expect from all of the things. So where are the asymptotes? Well, the asymptotes are easy this time. Nothing real complicated there. Down 4, 1, 2, 3, 4. Down 4, I'll make it dash in a minute. And to the left 1, right? Easy peasy, lemon squeezy. There's no B to worry about. There's nothing weird happening. So let's take and dash in those asymptotes. There they are. So that informs us where we're going to sit with our X's and Y's. All of those things. So our chart, X, Y. So let's pick these two. So -3, -2, and then 0 and 1 will be the ones that go with them, right? So f of -3 is -3 over -3 plus 1 is -2 minus 4. Now that's, well, you know, we could do that in our head and get -2.5. But for the more visual among us, let's chunk that in the calculator. Now, negative over negative is a positive, right? So we can just do 3 halves minus 4, and we do in fact get -2 halves, right? -2.5. So -1, 2, 3, -1, 2 and a half. Right, you notice that this is going to be over here in this new kind of quadrant 2, right? Because which is what we expect. We expect something kind of like that, right? More or less, not that exactly, obviously, right? But that's what we expect because it's flipped over, right? That's what that negative there is going to do, right? So there's our first point. -2. Let's do f of -2. -3 over -2 plus 1 is -1. Minus 4. Now that one I bet we can do in our head. This turns into 3 minus 4, which is -1. Okay, so -3, -1, -2, -1, 2, -1. So that's right here. Now that's a little bit weird looking because of the half. So we might go ahead and get one more point just to be like seeing what's happening really, really clearly without a whole lot of trouble. So let's go ahead and also do -1, 2, 3, 4. So -4. So f of -4 equals -3 over -4 plus 1 is -3. Ooh, that's nice. We like that. And then minus 4. So -3 over -3 is 1. 1 minus 4 is -3. So -3. All right, so -4, -1, 2, 3. Right? There we go. That's probably enough to be getting along with, right? Putting that in there. And connect those dots. Over there. There's that part. So this one, if we kind of mirror those across, this one, we kind of draw our line over, it may be hard for you to see, right? Where does that, what is, let's go ahead and shove it in the thing real quick. Let's see. Let's do f of 0, right? And we're doing this, and we're taking the minute to do this, just to remind you that you don't have to just kind of like, it's over here. If it's hard for you to see, just plug it in real quick. It doesn't take very long at all. 0 plus 1 is 1. Ooh, that's nice. -4. -3 minus 4 is -7. -7. So 0, -7. So that is right here. And let's go ahead and do one more. I got some blank space up here. Let's go ahead and do that one. F of 1 would be -3 over 1 plus 1 is 2, -1.5 minus 4. -1.5 minus 4 is -5.5. 5.5 negative, where are we doing? 1 and -1, 2, 3, 4, 5.5. Okay, now we're seeing kind of how we're going to connect here. There we go. We got enough to get on with. There we go. Easy peasy. And that is it for this lesson. We'll get even more exciting in the next lesson. We will see you there. Have a great day. Goodbye.